So here's an example of a series of questions you could answer if you know the position function. The position function is great. It tells you an awful lot of information about what's going on with an object. So here we have a particle moves along the line, so that its position at any time t greater than 0 is given by the function. Remember, our time is always going to be greater than 0 because we don't worry about negative time. So s as a function of time equals t squared minus 4t plus 3, where s is measured in meters and t is measured in seconds. So we can talk about the displacement, the average velocity or average rate of change, the instantaneous velocity, the acceleration, all these other questions too. For what values of time does the particle change directions? During what intervals is the particle moving right, left? Where is the particle when it changes directions? During what time is the speed increasing? During what time is the speed decreasing? A lot of questions we could ask, and we know how to answer. So let's get to it. So first of all, I want to find the displacement. Now, when we talk about displacement, we define it, we use t plus delta t, but let's make it a little bit easier. Just say, let's say the interval's an a, b. So then we know the displacement will be s of b minus s of a. In other words, where we finish, subtract where we start. So this question was on the first 2 seconds. So in this case, I'm going to have my interval will be 0 to 2. So that's going to be s of 2 minus s of 0. And that's going to equal, and then if I put 2 in here, I get, that's going to be, 2 squared minus 4 times 2 plus 3 minus s of 0. And if we put 0 in here, we're going to get 0 squared minus 4 times 0 plus 3. So you can work this out. I'm just putting these steps in just so it's perfectly clear. Oops, there we go. 2 squared is 4, so 4 minus 8 plus 3, and then minus 3 over here. These are both 0, so we just have negative 3. And negative 3 and 3 is 0, so 4 minus 8 is negative 4. So negative 4, and that would be in meters. That would be the displacement. Okay. Letter B on this list here. Find the average velocity during the first 4 seconds. So now we want to find the average velocity from 0 to 4. And the average velocity is just the slope there, delta s over delta t. And that's going to be, delta s is s of b, so that's going to be s of 4 minus s of 0 all over okay. And you could, kind of think of this formula on AB, then ds dt, or delta s over delta t equals s of b minus s of a all over b minus a, and this just looks like our average rate of change. We've used that before. F of b minus f of a all over b minus a. So this is just s, but that's the same thing, and that's the velocity. That's the average velocity. Sometimes we use this little note here, velocity AV. So that's what we're going to do, s of 4 minus s of 0 all over 4 minus 0. And like I said, this is a good formulatic way to remember what we're doing. So it's s of 4. Well, if I put 4 in here, that's going to be 16 minus 16 plus 3. Minus, and then if I put 0 in here, 0, 0, that's going to be 3. All over 4. Minus 0, which is 4. And that just ends up being 0. 0 over 4. Oops, sorry about that. There we go. All right. So the average velocity, on the interval 0 to 4 equals 0. That's my average velocity. Okay? Now we get into the good stuff. Letter C, find the instantaneous velocity when t is 4. So how do we find the instantaneous velocity? Well, we had kind of a formula from our notes. that the instantaneous velocity over here equals the derivative of s with respect to t. So s of t equals t squared minus 4t plus 3. So the velocity as a function of time is just the derivative. And that's just going to be 2t minus 4. And we want the velocity at 4 seconds. Okay, find the instantaneous velocity when t is 4, so I just put 4 in here. And that's going to be 2 times 4 minus 4, which is just going to be 8 minus 4. And that's going to be 4. And that's velocity, so that's going to be meters per second. Okay. So that's the velocity at any time. Okay, for what values of t does the particle change direction? Well, it changes it has to stop, right? You can't change directions unless you stop. So it stops. Oh, I'm sorry, I skipped one. C, D. What's the acceleration of the particle? T equals 4 seconds, excuse me. Acceleration, that's D. Well, the acceleration we know is just the derivative of the velocity. That's also from your notes. If you look back there, you'll see that. Right here. Acceleration is the derivative of the velocity. So I just take the derivative of the velocity. So my velocity as a function of time equals, let's see, equals 2t minus 4. So acceleration equals the derivative of the velocity with respect to time, which is just 2. Now that's going to be meters per second squared, so because that's our velocity units, meters per second, and that's just 2, and that's a constant 2. So you see we can find the displacement, the average velocity, the instantaneous velocity, and the instantaneous acceleration. And it's always 2, so no matter what, it's irregardless of what. All right, so there's 4 pretty good questions. We'll continue this.